Welcome. You are watching episode 14 of 90 Minutes to Close the Loop, the web series on glass collection and recycling. In this episode, you will be hearing about glass crushing and its impact on closed loop recycling. You will no doubt be familiar with this sound, as the bottles and jars you bring back for recycling are deposited into the bottle bank. And it's an aspect of glass that will be critical throughout the whole recycling process. It breaks. From the moment it is brought back, it starts to break. It will break further when it enters the waste management phase and the bins or bottle banks get collected by a truck. And the glass can be further broken down inside the trucks as more and more glass gets collected before it is delivered to a glass cullet recycling facility. And as it breaks down into smaller pieces, and even more so if it is pulverized or turned into dust, it can become harder to sort out the glass from the other materials. On the other hand, glass is bulky and takes up space, so some level of breaking down is necessary to optimize collection and waste management logistics. So, does glass have a crush? This is what we are going to find out to define the right balance between optimizing collection and optimizing the final outcome that we all aspire to, closed loop recycling. At Close the Glass Loop, it is a priority to continuously optimize the closed loop recycling process. In our roadmap, we explain that within a glass cullet recycling facility, after a preliminary sorting phase, glass is broken into a size range between 3 and 50 millimeters. This is crushing in a controlled environment with the necessary equipment to make the material fit for purpose for further closed loop recycling. But one of our priority actions, and today's discussion is very much a part of this, is to develop good collection and handling principles for waste management operators. Now, this is crucial because, as we have demonstrated in the recent publication of the 2024 Performance of Packaging Glass Recycling in Europe report, closed-loop recycling of glass packaging is done in a very short chain, largely based on municipal waste, then a sorting process to remove non-glass materials, and finally a manufacturing process that produces new bottles and glass. 85% closed-loop recycling of all collected materials may seem like a very high figure already, but there is a big appetite for more. And the challenge today is to ensure that glass crushing does not mean material ends up outside of the closed loop, or even worse, outside of recycling altogether. So to help us tackle this issue, we are joined by a superb lineup of speakers. Federico Salvati is manager for glass recycling projects at Sibelco. Welcome, Federico, and thanks a lot for joining. We have Simone Orsi, circular economy expert at AMSA, part of the A2A group. Thanks for joining, Simone. We have Constantin Damov. He is the chairman of GreenGroup. Thanks, Constantin, also for joining. And finally, Tommy Griffiths, the CEO of PEL. Hi, Tommy, and welcome. So we'll start with a presentation from each of our speakers, and then we'll be engaging in an open discussion. As usual, please get involved in the chat and Q&A, as I will be raising your questions and comments to our speakers. Now, you were more than 100 to register for today's episode, and you're coming from 26 different countries. So I think this really shows there's a big interest in this topic, in the whole industrial side of the recycling system. And we also have a good representation today from glass manufacturers, the waste management sector and recycling, as well as extended producer responsibility schemes. Really great to see, by the way, interest also from HoReCa and distributors, as well as public authorities. So really welcome to all of you. And I propose that we get started. So first up then, to give us a sense of a first case study is Federico from Sibelco. Now, Federico will be giving us a little bit of an overview of some of the challenges around glass crushing and its further recycling, with an overview also from a European perspective, as Sibelco is active in several countries. So please, Federico, over to you.
Okay, so nice to meet you, everybody. So I'll start with a first slide to get you a first touch point on where the contamination actually is in the glass and what it actually looks like. So you can see that much of the CSP is concentrated always in the coarser fractions, where it can reach up to 15, 20, even 25,000 ppm. So 2.5% of the infill material in this fraction can be actually CSP, so ceramic, stones, and porcelain. But in these fractions, it's generally represented by a very few large objects. So these large objects are easy to detect and eventually easy to reject from our material flow. If we go then to have a look at the smaller fractions, we can see that the weight of the contaminations decreases and it reaches 3, 4, 5,000 ppm, depending on the country where the glass is collected and the collection point and the people behavior and so on. But the number of actually infusible pieces exponentially increases. And by the time we reach the very fines, so the fraction between 1 and 2 millimeter or the fraction between 2 and 3 millimeters, we see thousands of little fragments. Each of those can be a potentially defect in our customers, so in the factories where bottles are produced. Larger pieces are then usually easy to detect and eject, while the smaller pieces, they will eventually reduce the sorting capacity and the sorting efficiency of our machines. The effect of particle size distribution, it's very evident if we plot it against the sorting throughput in an optical machine. And you can see that in the very coarse fractions, so let's say if the pieces are bigger than 14 millimeters, it's quite easy to get very high throughputs in the area of 10, even 15 tons per hour on a single optical sorter. And the efficiency of separating these CSP pieces is very high, as you can see from the difference between the input stage on the first line of pictures and the output stage on the second line of pictures. Then if we move to the medium fractions, let's say around 6, 7, 10 millimeter in size, the efficiency that we get is still very good. You can see in the purple bucket, we just have a few CSP pieces after the first step of sorting, but the throughput is starting to decrease quite significantly. From 10 or 15 tons per hour, we move down to 8 or 6 tons per hour only on a single machine. Then by the time we go to the very fine fractions, the throughput is dropping to 1, 2, maximum 3 tons per hour. And we see also a decrease in efficiency. That's because the small pieces are harder to detect and even also harder to eject from the material stream. Also, we see the effect of starting with thousands of pieces of CSP in the input. Then, even if the efficiency is still maintaining 90, 92, 95% of efficiency, the output still contains many of those input pieces. Therefore, leading to a case where only one or only two steps of sorting are not necessary to provide a final product which is in spec for our customers. Therefore, more steps must be put in series to go to final quality. Then the big topic of today's discussion is the effect of crashing the glass before it reaches our recycling facilities. So, of course, like you say, Jean-Paul, in the introduction, the glass at a certain point in the production flow will be crushed, but it all depends on how it is actually crushed. So it's key that the glass is properly calibrated to ensure a good recyclability of the product. And in fact, the glass must be coarse enough that we can sort it easily, maintaining a high efficiency and high performance of our process, but not too coarse that we get clogging and pieces stuck inside of our optical sorters. So the glass is not just crushed in any way, but we use dedicated and specific machines to do the job. These are generally roller crushers, and we design them to apply just enough force, the minimum amount of force, to break the necks, the bottoms, very thick pieces of glass, which are the very strong ones that really needs to be crushed, but without wasting energy and without going to a full crushing where we break the weakest part of the bottles, for example, the body of the bottles. Also, we don't do an indistinct crushing on site, but we only crush what really needs to be crushed. So only the particles that are larger, for example, than 50 millimeter get crushed. What is already below this size is left untouched and will then eventually go directly to the optical sorting stage. This said, we see how compactors, shredders, plastic bag openers, and basically any other type of crusher that is not a roller crusher is creating an indistinct and uncontrolled crushing of the full fraction of glass. This will then generate an increased amount of fines, and an increased amount of fines will then lower the recovery of glass itself and therefore limit the recycling rate. So for sure, crushing glass will have a very positive impact on the upstream collection, because for sure the space that glass is occupying inside the truck or inside the bin is less, and then everything can be optimized. But then when it comes to the glass recycling facility, then we have an issue, because the finer the glass, the more waste we eventually produce. And of course, nowadays, where for the municipalities or private company, the glass is actually a product, it's not a waste anymore, it has also a value. But the value in a free market dynamics, it's given by the profit or the recyclability that company like Sibelco or other recyclers can get out of the glass. So a glass that is coming to our processes more crushed than usual could also limit the market value of the inbound material itself. Finally, a last slide from my side is about the current capabilities of the optical sorters. So in the past, it was common practice to sort glass down to 10 millimeters, then eventually down to 8, to 5, and so on. Nowadays, we are not limited anymore by the detection of the infusible particles, because if you take specific industries, such as the food, such as the seeds industry, they have machines that can go down to 1 millimeter, no problem. What is really mattering is the efficiency of sorting and the performance and the throughput that we can put in a given optical sorter. So we see that the number of infusible particles is very high in the fines. What does it mean? That for fine fractions, we need more sorting steps in series, because we need 1, 2, 3, or 4 steps to completely remove as much as possible all the thousands of pieces that we find in the input. But also, when we deal with fine fractions, we need more sorting width, meaning more machines in parallel. This is because we saw in the previous slide that in the fine fraction, the throughput capacity of optical sorters is decreasing, and then to perform the same job, the same ton per hour, we need more sorting width, meaning more machines in parallel. Also, when we're dealing with fine fractions, we see that it becomes difficult to sort paper from glass. Paper is normally sorted by means of air systems, so this can be suctions points, can be cyclones, can be blowers, can be air knives, but all of them, they exploit the difference in weight between paper and glass. However, in the fine fractions, and especially when the paper is wet, after having absorbed the humidity or the moisture or the water in general, glass and paper tend to have the same specific weight. And then it will be very hard to remove them by way of air cleaning. What does it mean? That we need to remove paper with the optical sorters. So we need to demand this task to the optical machines, which normally are only shooting out CSP. These machines, every time they are expelling an object, they are creating oversorting, they're losing glass. So if you can see in the picture on the bottom right of the slide, it's a nice example where to eject one piece of ceramic, so the red particle surrounded by green glass particles, the valves will open for 1, 2, 3, 4 valves in series for a certain period of time, which is the vertical arrow. And just to hit one ceramic piece, we will discard all the glass pieces around. So for every fine piece of ceramic that we hit, we might be losing 10, 15, 20 pieces of glass around it. So in conclusion, the higher amount of fines that we see in our plants will give us an increase in capex because of more sorting power is needed in our plants, an increase in opex because of additional running costs, for example, the compressed air to shoot them out and the maintenance and so on, but also a higher oversorting leading to a high waste cost because some of the particles of glass will be expelled with the fine CSP and eventually exit the glass loop.
Okay, brilliant, Federico. So you make the double point, right, on the recyclability on the one hand, and the smaller the pieces, the finer the pieces, the more complex it becomes for recycling. But then also in terms of cost effectiveness of the whole process, right? One immediate question for you. For the parts of the collection process that can increase these finer fractions, so through the logistics, or you mentioned compaction trucks or the plastic bags, things like that. Are you able, through specifications with municipalities on the material that you're receiving, to limit that, or is that quite difficult to have an influence over the types of processes that are chosen by municipalities?
So from our point of view, it's not always that easy because I'm expert for Italy, so maybe it might be different in other parts of Europe, but you have to deal with every municipality. So in Italy, we have like 8,000 municipalities. So imagine you have to deal about this subject with all of them. So it can be easy with the bigger cities where we have maybe a single point of contact, and with one, let's say, target, you will already act on 1 million inhabitants. But then if you need to do this for every single municipality in the small towns of Italy, that's going to be really difficult.
Yeah. Okay. So it's possible, but it's mostly the numbers that make it very
Yes,
challenging. Okay.
exactly.
Thanks, Federico, and stay with us for our open discussion afterwards. So on the topic of municipalities, our next speaker is Simone Orsi. He's circular economy expert at AMSA, part of the A2A group, and Simone will be telling us specifically about the case study of Milan and how the city of Milan goes about collecting and delivering glass for further recycling. So Simone, over to you.
Hello, welcome everybody. I'm happy to be joining you today. So I will talk about first a little introduction about Life Company. We recently rebranded as a Life Company because our services have a specific impacts on the life of people. So we are present in Italy with energy, gas distribution, heating, and of course environmental services and waste collection and treatment. So let's dive in deeply into the waste management in Milan. So we are sending 100% of our municipal waste to material recovery and energy production. We don't have a landfill in Milan since 1997. We reached 63.4% of separate collection in Milan, which is, I believe, a high rate for a city as big as Milan. We perform, door-to-door collection system. This is our key to good quality recycling, and we basically have 55,000 pickup points in the city. And we recently, invested in trucks, and we have 1,400 waste trucks they have low emission vehicles. They run on biomethane and electric. And of course, we have to deal with the customers, which is the city of Milan and all the citizens, and we try to be present 24 hours a day without giving answers. And we have been awarded with a good satisfaction rate on average by our citizens, so we're happy about that. So yeah, this is the cycle. We really consider all the materials as resources. So the first thing is to, of course, to separate collection and to recycle the materials. And we have, a very high, door-to-door collection system. Is performed through the whole city, and we have a mixed, system with bins and bags. Bins with for glass, organic waste, and paper, and for plastic and metals and residual waste, we have the bags. And we and the waste is stored in every building, so it's not on the street. There's virtually no bring banks in the streets, so that we really can control better the quality of the material, because the quality is very important. The door-to-door waste collection is a tradition of Milan, and it was performed since the beginning, and always was a tradition in Milan. So really, it's difficult, when you have a city like Milan with many high-rise buildings, and of course, and a few single homes to tackle the quality of the collection. So, but I think this is something that we discuss with the other cities around the world. That since we have these waste rooms, this is an example of within our buildings. We have bins and bags, and also the requirements made by the city of Milan require this new buildings to have a waste room, and with at least 0.18 square meter per inhabitant for each building. And that is really important. So now let's go into the glass pickup service and how it is done. So we have the door-to-door pickup system, only glass. So glass is not mixed with, for example, metals. In other municipalities, you can find in Italy, for example, you can find this also this mixed with metal. So only glass. So this should be very, very good quality. And we use 120 at 24 to 40 liter bins. Only 13 bring banks still in place, but soon to be dismissed. We used to have more bring banks, but now we really focus on door-to-door collection. And of course, I think this also helps avoiding crushing, because you go into your building and you dispose of the waste of the glass in this and with no plastic bags, just glass. And we collected 66,000 tons of glass in 2024. This is 10% of total municipal solid waste, and it's an average of less than 50 kilograms per capita. Our teams, we perform this with the standard team or mono operator teams. The majority is made with standard team, which is one driver, one operator, using the Stummer truck. Now it's very, very new, and the other teams are mono operators, so just one driver operator in smaller streets, and this accounts for 31% of the teams. So we invested a lot in the renewal of the fleet, because we recently won the tender for the municipality of Milan to run the services, and we are about to introduce over 300 vehicles in 2025 with a replacement rate of 40%. And just to avoid crushing, we have this system. So this new 28 Stummer truck they consist of 24 cubic meter container. They use these augers. They have the task to distribute the loaded waste inside the camera, but avoid crushing, so there's no pushing of the material. And other, of course, we are concerned about safety and of course to have to speed up the collection times, because of course we have to be very quick in doing this in the streets, just to avoid traffics. And so we have the automatic bin lifting device. We have a load limiting device when the useful capacity is reached of 10.9 tons. We invested in eco fuel, so biomethane powered and lower emissions for the compared to diesel. Next. So the important thing is that glass noise is also a very something that is concerning our citizens, because we perform the collection early in the morning. So we very recently developed a technology with our partners. This new technology, which is glass noise technology, is developed by Phononic Vibes, a startup company of the Politecnico di Milano, so right here in Milan. And with this special sound absorbing sheets are used for the tank and some functional elements, using this meta layer technology, which helps reduce the impact of noise by 50%, and hopefully also maybe have an impact on crushing. We don't know, but maybe could probably be the case. And so here are some demonstrations where recently our mayor visited our facilities. Going through our composition analysis. So here's a recent analysis of what we actually collect in AMSA, and you can see that the glass over 10 millimeter is 88.86%, 9.15 glass less than 10%. Of course, the problems are with the infusible, which are 0.45 still. So we also invest a lot in communication, because we have to, of course, the particle size is important, but if we can limit the infusible parts, so we invest a lot in communication, just to made aware that the citizens that ceramic and other packaging are not to be put in the glass fractions. And okay, the average quality of the Coreve is the national consortium, is of course it varies. It ranges between A, which is the best quality, and D, but average it's C. So we hope we're doing a good job. And this is very quick. We send our glass to the ST glass cullet treatment plant, and as was previously mentioned, we have the screen, the optical selection, which is really important, using this optical selectors and X-rays to really get rid of the impurities. And also so this plant is quite new. It was made in 2007, and also we have a photovoltaic plant on the roof that covers 60% of energy necessary to run the plant. This is our some information about the plant. 180,000 tons a year of glass cullet. That is the production of 4.5 million people in 1 year, and the output is so glass and the waste 73%, and the glassy fraction 60%. Metal fractions are about 4%, and 7% is what is sent to landfill. And yes, this is what a little insights of input and output of the plant. So here, of course, you have other cities, sending glass to this plant, not only Milan. That's why you have some more metals and to get rid of, and infusible material, and of course crystal and lead glass, and that is the output that is going to the OI manufacturing company that's right beside this plant. So this is everything, and hope
Brilliant.
it was I went through a lot of topics.
Thank you. Well, I mean, you're on the collection side, so you're exposed to many different things. You talk about the noise that glass makes when it gets broken, and if you're doing that at several stops early in the morning on your tours. Next to every single building, I can imagine that's an issue. So that's definitely an interesting one. A couple of questions for you. One, not specifically related to glass, but as you mentioned, in Italy, sometimes glass is collected with metals. You said that in Milan it's not. How are metals actually collected then in Milan?
It's collected with plastic. So we have plastic and metals. So basically, in our treatment facilities, we separate metals from plastic.
Okay, brilliant. Another one for you. Do you also collect
of course.
cork? Do you also collect cork from the wine bottles? What is the recommendation to citizens to sort of separate the cork and the bottles? Do you know?
Yes, of course. We say that get rid of all the metals and removable parts, at least. So yeah, for example, metals have to be put in with the plastic fractions. For corks, we say that we have also organic waste collection, so actually can be put in the organic fractions.
Okay.
Yeah, I think people are respecting this
Recommendation, let's say. Yeah.
yes, this recommendation, yes.
Okay. And maybe last one, same question in a way to Federico on the question of the specifications. So in your case, you are collecting for the city of Milan, but you're also then recycling the glass. So let's say it's relatively integrated. So I guess you have an interest in not crushing too much in your own collection system. But in cases where you are receiving material from different municipalities, how much do you feel specifications help to ensure that the collection logistics are not crushing the glass too much?
Well, okay, I will. Well, I think, of course, it's always a balance. Okay, actually, AMSA doesn't receive, material. We actually collect in all our municipalities. So probably it's our cousin from the plant that maybe are concerned about this. So I think it's a balance of collection activities and, of course, the treatment activities. So I think or internally, I think we balance these two opposites, say maybe opposite, requests.
Okay, brilliant. Thanks a lot, Simone, for your insights. Stay with us for the discussion. Maybe it's a good time actually to run a quick poll with our audience. I'm thinking that it would just be interesting to ask you if you agree that making collection and collection logistics as convenient as possible is key, even if it means crushing glass. So do you totally agree with this statement? Somewhat agree? You think it makes no difference either way? Somewhat disagree or totally disagree? So, you can leave us your answer. We'll be coming back to that in our discussion as well later on. In the meantime, I will then introduce our next speaker. So we've been talking about, obviously the challenges of receiving crushed glass. We've been talking about the case study of a municipality with Milan. But that's not the only source for collecting glass. In the case of Romania, a lot of glass is actually collected through a deposit return system, which has a crushing challenge of its own. So over to Constantin to tell us a little bit about the situation in Romania with glass crushing and DRS. Constantin, over to you.
Thank you, Jean-Paul. Thank you for inviting me to share with our friends the news from here, because we're going through a dramatic change of the way of collecting the glass waste in Romania. As everybody may know, just 2 years ago was a disaster and the very low figures for collection and recycling for glass. Then it was a push by the government that glass will be part of the DRS. So we'll discuss about crushed versus uncrushed, but in parallel also about the DRS and non-DRS collection. So I will introduce our company. It's called Green Glass Recycling. It's a member of GreenGroup. It's a larger group of recycling activities. Here we'll talk about our glass division. It was established in 2013, and we have an installed capacity now of 110,000 tons a year near Bucharest, the capital of Romania. And, well, glass market, last year, 2024, was in a range of 470,000 tons placed on the market. And we've seen already during the last year that the DRS glass containers put on the market have been like 327,000 tons, and the difference, about 143,000 tons, was remaining for municipalities. So now the ratio of responsibility of glass collection, it's moved totally on the side. I'll say the gravitation is a lot on the side of DRS, like a 70% versus 30% collected by municipalities. And we had such results. Actually, they are very fresh. 90% is a DRS rate of collection in January, February 2025. I will say it's amazing to reach 90% in less than 1.5 years now, which means that consumers have been embracing this solution and is really working. On the other side, the municipal collection, it's steady growing, but it's still in the range of 60%. And we see here a lot of work to continue to raise the results. Well, the Romanian deposit return system, it's called Returo, it's a name, was launched in November 30th, 2023. And the stakeholders are the industry, the fillers, 55%, retailers, 25%, and the government, 20%. Even we didn't like, somehow the government wanted to be part of this company with the minority shares. Then it's a nationwide coverage. Practically, it's from big cities to small villages. The system is working either through machines like a RVM. There is a photo on the left where we can see it's our Minister of environment. The opening was the first glass introduced in the system. And this will go to the small villages where it's a manual collection. And then the system will include containers between 0.1 liters to 3 liters in volume, and materials is PET, aluminum, and glass. One of very interesting thing here, it's probably there is no other deposit reversing system. It's a lot of glass in, so it's not only beer and water, and soft drinks, but also we have here wines and even spirits. This was irritating some of the producer, but that's how it's working today, the system. Well, why does glass need a crush? I have been asking the DRS, and there is an explanation. Actually, they have two answers to this question. We are talking about a fraud prevention. So if PET and aluminum can be deformed, pressed, the input at the machine, glass, if it's not crushed, can be double or multiple redemption. And to avoid the double redemption attempts, the decision was the container has to be crushed and not to keep his integrity, to be used again. Also, transport efficiency. There is a higher density, it means a lower transportation cost, and of course also lower emissions. We have been counting some crushing effects. Actually, it's a pre-crushing, we will say, because it's during collection, is not the crushing within our plant on recycling. And I will give you some figures now. So the density of the material resulted after this pre-crushing in the reverse vending machine in the supermarket, it goes to 600 to 650 kilograms per cubic meter as a density. But we found some other effects which is very, very specific to this system. By crushing, dust and the fines is generated during collection in the supermarkets. And that loss, it counts from 2% to 5%, and it comes from the big bottle over 500 milliliter to 3 liters, generates less fines, like 2 or 3%. But when we speak about small bottles like 300 milliliter or less, we are moving to 5%. So it's a considerable loss, material that is not arriving to our recycling plant. It's lost just there in their waste. And we have another thing, a fresh label effect. Because bottles are very clean and very fast collected after using, without any storage, intermediary storage, we have the fresh label, which are very well stuck to the bottle, and we have then a problem to detach the labels from the glass. And at the first running, we have 8 to 10% rejected material, which we have to leave it for 1 or 2 months to have a degradation of the labels, majority being paper. So we have to run again this quantity. This is an effect we didn't anticipate at the very beginning. We can see here how material looks now on these 2 flows we have on collection. On right, you can see non-DRS. It's a contaminated material. Also, inside we can find, as usual, CSP. But on the very left, we can see the uncrushed bottles that they look as new. In the middle, we have a DRS crushed material. Well, we make some recycled test results, and this is a very rough. We have been running like 20 tons of which type of material, like DRS uncrushed, DRS crushed, and not DRS material, municipal. We have been obtaining the following rejects: 17, 19, and 24% at the first running in the plant, which means that it's clear that DRS, we want it or not, it's bringing better material and higher purity. And it's a difference between crush and uncrush. Obviously, uncrush from DRS is the best material, we can have it. We have some key findings, which I would like now to underline. If we compare DRS with non-DRS, we'll say that the DRS material is giving a higher yield. This is something new. Practically, we have a zero CSP content because at the machines, you cannot mix the material with any stones or porcelain and ceramic, because simply the machine is not accepted. Then we have also seen a 50% reduction savings in the energy for the dryers, because material is really very nice, doesn't need too much of drying. And also we have been seeing a longer lifespan. Practically the life is double for the filtering system that is capturing the dust. But also we have a negative impact, DRS versus non-DRS, the fresh label effect. So 8 to 10% we need to reprocess. DRS crushed versus DRS uncrushed, it's not very much to talk here about. Just the crushed material is giving a lower transportation cost by having a higher density and less CO2 emissions. And also we can see a lower yield in the case of crushed DRS material. But what we have to count in the system, it's at the collection at the very beginning, between 2 and 5%, it's additional loss by crushing on the flow. This has to be evaluated for reporting in the next years to understand how much is collected, how much is recycled. Well, thank you for that, and I'm looking to hear your question.
Yeah, thanks for crushing or crashing. Thanks for crashing the discussion, Constantin. Okay, brilliant. Thank you. Actually, yes, we have a question, and I actually had the same question, so I'm going to run it also from the audience. It's on this loss at the point of collection. So we understand there is a crushing at collection in the machine at retail, let's say, and you're saying there's something like 3 to 5% that is lost. Why exactly is that? I mean, why isn't all the glass potentially crushed but then sent to you? Does it mean there's a kind of a pre-sorting phase after the bottles have been collected in the reverse vending machine that happens somewhere near the retailer or in a specific facility? How does that work?
I was saying the first concern is fraud. People is concerned, I mean, DRS people is concerned that the bottle can be taken and put again in the machine and again into machine, and people will have reimbursed every time some 10 euro cents. And the temptation is very high. That is the first discussion we had with DRS, and we cannot say anything against that. And also we have the crushing. It's just the crusher. It's inside the RVM. It's a special demand of the DRS system in Romania, and they are running with a quite high speed, I will say, because people cannot wait too long in front of the machine. And then high speed will also create many dust and fines that eventually will stay in the machine, not going to be delivered to us, and that they are counting as waste during collection.
Okay, so it's almost like a residual element of the collection that doesn't go anywhere, and I suppose maybe gets even disposed of in one way or the other. Okay, interesting. Thank you so much, and great that you were able to show some figures as well on the test. Maybe we can go a little bit more into some detail in the discussion. Stay with us then, Constantin. Our next speaker is again looking at another type of collection model, quite specifically targeting the HoReCa sector, I should say, with some very specific equipment that makes it a little bit more convenient to collect the bottles behind the counter. So, Tommy, over to you to tell us a little bit about the kind of service you are offering.
Jean-Paul, thank you very much. So, we're based in Ireland, and we've been manufacturing equipment for just over 20 years. My history as an engineer, grew up on an agricultural farm here in Ireland, and I worked after college. I worked for an agricultural engineering company in research and development. Then I was in pharmaceutical industry, and I was looking for opportunities to start my own business. So in 2005, I just started to set up a company, and I developed products for reducing glass waste. And why did I go after glass waste as such? Because here in Ireland, there was a lot of volume. There was a lot of issues in relation to the hospitality sector. Volumes of glass at source. Waste companies weren't collecting glass, and there was opportunities. So since 2005, we developed a range of machines for reducing glass waste. And I suppose we'd rather say reducing glass waste than actually crushing glass waste. Because the glass that we create from our products is a coloured format. And that's from 8 millimeters up to approximately 50 millimeters. So our whole emphasis as a company is to ensure that the glass that goes through our products is going back for reprocessing. It's not going for aggregate, it's not going for landfill, it's going for reprocessing. So over the next number of years, since 2005, we increased the range of products for glass waste, depending on the type of customer, depending on what product we actually manufactured. As a company, we've been lucky enough to win numerous awards for innovations. We export products all over the world at this stage. And I suppose it's interesting to say that every country has a different legislation. So certain countries, yes, we go after the market. Other countries, we don't, where the legislation mightn't be as suitable for the product, or where there's certain deposit return schemes in place, we mightn't go after that. We go after the hospitality sector because there's a lot of issues at the hospitality sector with the volumes they create, and that's why we're going after that sector. So we just don't do bottle crushers. We do other machines for reducing waste. We develop technology now. So as a company, we can monitor our products anywhere in the world, and we use photo image bank for bottle detection. So again, when we're in the hospitality sector, we know exactly what bottles are going through our products at any given time. We manufacture our products here in Ireland, and we distribute around the world. We now also have a manufacturing facility in India, where we're targeting the Indian market, and we have our own team based in the US market as well. So in Ireland and the UK, we sell direct to the end user. Throughout Europe is distribution, the States, distribution, but we have our own personnel in there, and in India, we're direct to the market. So the whole concept of reducing glass waste has to be a win-win for everyone. And we talk about the closed loop concept. We talk about it from the manufacturing of the bottles through to the distribution, the bottle drinks manufacturers, through to the hospitality sector, whether it's a waste company or whether it's reverse vending, it's gone back for manufacturing again. But it has to be a win-win for everyone. It has to be a win for the manufacturer. They're not using virgin material. It has to be a win for the bottled drinks companies because they're the ones that are putting the bottled containers out onto the marketplace. When we look at the hospitality sector, they're looking at costs. They're looking at volumes of glass. If we're in built-up areas like the cities like London, Paris, cities all over the world where space has a huge value, they can't afford to have loads of bottle bins sitting in their waste areas or in basements or in street locations. So it has to be a win for them from a labour point of view, from a segregation point of view, and from a space point of view. And then when it gets back to the collections, we're reducing the volume by up to 80%. So therefore, we're reducing the trucks on the road. And again, from the hospitality sector, if they miss a collection and have storage space, they run into issues over week-long periods. So the closed loop concept that we see is that we bring the glass to a cullet. The glass cullet that we produce goes back for remanufacturing and back into remelt. So how do we do it? We manufacture a range of products depending on the customer. So if we take Baby Jaws, the BBO1, that little machine is the only bottle machine of its type in the world that can go in under a standard bar counter. So when the bar staff take the bottles off the counter, it goes into the machine and it's brought to a cullet format. So that glass is handled at source. So there's no risk of contamination. Whereas in bars, if you have bins behind the bar, the glass ends up contaminated. So when there's a machine there and when it's a product and it goes through a circular opening at the top corner, it goes in at the top, it goes around, and it goes into the chamber where it's brought down to a coloured format. The BBO9 fits out in the public area, and that's where the waiters or waitresses come up and they put the bottles into it. But in that situation, that's in cities where that glass has to go out every night. So they don't have space for storage. They cannot have tin bins at the back house. They don't have that space. So the machine stores the glass during the day and it goes out at night. Then when we look at volume-fed machines, we do what we call a BBO4 and a BBO6. That's generally in hotels, and that's at the back of house in the waste area, where the glass may be coming from 4 or 5 bars. It comes out to the back, it's put into the machine, depending on whether it's indoors or outdoors, depends on whether it's a BBO4 or BBO6. That glass then, that machine can handle 680 bottles in under 10 minutes. The glass goes into that and it ends up in a 120 or 140 litre wheelie bin. The 22 is for breweries, and that's generally where we'll fit it into production lines where the glass, where there's rejects or where the containers filled with liquid that they don't want going out into the marketplace. The glass goes into that, we separate the liquid from the glass can go for recycling, the liquid goes back into for biomass or bioenergy plants. So where is the win-win for everyone? If we look at the manufacturing container manufacturers, we're reducing the use of virgin material. So straight away, they can use the cullet that we're producing. There's less energy used for the production of the containers, there's less water used, and it's more sustainable. And that's glass that they've put out into the marketplace coming all the way around. And that also goes for the drinks companies. They're the ones that are putting the containers and the packaging out to the marketplace. So there is responsibility for them to ensure that that product gets back to remelt again. And again, from the collection points of view, we see a lot of the big suppliers of drinks, the likes of France, who are putting it into one of the big drinks companies. They put out the small bottle crushers, Baby Jaws, in under the bars. The glass is stored in a blue tote box, which then seals. Each tote box holds approximately 90 bottles, and they bring that glass back. So they supply in the bottles and they take away the bottles. So now they're getting rid of the trucks off the road in relation to reducing emissions. So it's all sustainability. From a distributor point of view around the world, every market is different. No matter which market we go into, there's different issues within it. But again, the drinks companies are looking at ways to ensure that their glass is being returned. So we're introducing into markets, whether it's in Ireland, whether it's in the UK, whether it's in France, whether it's in Poland. Different markets have different legislations, so different markets have different issues. Customers, again, for the hospitality sector, in built-up areas where there's congestion charges, where they don't want trucks coming into the city centres, we have to look at ways of reducing the volume of waste being created. So by bringing the glass to the cullet ensures that we're reducing the volume by 80%, so we're reducing the trucks on the road. and it's our responsibility. As companies, we want to ensure that sustainability, the environment has been protected, and that the glass is going for recycling and back into glass again. For the hospitality sector, it's a huge issue. Volumes of waste, volumes of glass is a problem. So by introducing our products, we're reducing the volume by 80%. So their storage space for storing waste bottles is reduced by 80%. They want people on seats. They make money at peak times in the evenings, so they can't afford to have space taken up with bins. They want people in it. So they're creating more space for seats for people, for customers, paying customers. By doing it at source at the bar staff are doing the work and own to themselves. So now they're grabbing the bottle off the top of the bar, they put it into the machine, and it's brought to a colour format. So they're increasing staff productivity. If we take in built up areas or busy places where there are large volumes of people coming in socialising, if a person has to wheel a bin out from the bar, out to the waste area at the back of house, generally we've worked it out that it could take about 10 minutes. They make money from 10 o'clock at night generally till the hours of the morning. So by reducing the glass at source, the staff are working behind the bars at that time. And again, contamination. We're reducing contamination because that glass is going directly into the machine and it's clean, coloured. Whereas if we look at markets where there's single source recycling, the biggest issues bottle processors have is contamination. And I know in the US market, there's mountains of bottles contaminated. So the win-win for everyone is the bottle manufacturer, the bottle distributor, the hospitality sector, and then it's back for remelt to the environment. And when we look at the environmental benefits, we're reducing the number of trucks on the road, right? From collecting the glass from the hospitality sector to the glass going from the processors all the way to remelt. We're reducing the segregation at source. We're reducing noise. Noise was mentioned a while ago. So when we crush the glass, our machines run at a very low noise level, so you don't even hear them behind the bar. If you're emptying bottles in built up areas at night, there's a huge issue with bottles being tipped. Whereas when it's cullet, there's no noise. It's very low noise, so therefore it's not clinging, it's not very sharp, so we've reduced noise level. We've greatly increased the energy efficiency of it, and then we've traceability. So now, if a hotel has 100 sites, from a touch of a button on our software and our technology, they can see every site. They can see exactly what bottles have gone through each product at each site. So two ways that helps them. One is from stock control. They can know if there's stock is correct or if it's not correct, or if there's bottles that aren't supposed to be there are there. Two, they can know that the throughput that the glass is being brought to a colour size for recycling, but it gives them an efficiency. Plus, from the hospitality point of view, they now know that they're recycling. They now know the benefits of what they're actually doing. Sorry, just to move to the next slide. Sorry. So the conclusion, as a company, we're pioneering the closed loop concept as well. We're producing products to reduce glass volume, to bring it to a colour, to ensure that it's reprocessable. As a company, innovation has been the core of what we do, from being a mechanical engineer to being just mechanical products to have now technology that we can monitor our products anywhere in the world. So innovation is the core of what we do. It's a win-win for all. It has to be a win-win for the collection companies. It has to be a win-win for the manufacturers of bottles. It has to be a win-win for the drinks companies that are filling the bottles. It has to be a win-win for the hospitality sector. Everyone has to win on it so that the environment is being protected. We're reducing our carbon emissions, we're reducing our carbon footprint, and glass is sustainable. It's reprocessable. And that's the push that we see it as a company. We're pushing towards glass. PET is a day of the past. So I thank you for your time. I thank you for the opportunity to tell you who I am, what we do as a company manufacturing machines for reducing glass waste. And I'm very interested in anyone that wants to ask me a question. Please do. Thank you very much.
Thanks a lot, Tommy. You're talking about a sector that we estimate through. We did a study on the HoReCa sector, and we estimate that one-way glass, so glass for recycling, represents around 20% of all the glass placed on the market in the EU plus UK. So one-way glass in HoReCa. So it's about a fifth, So we know that in some countries it's a lot more, where there's a lot more density of HoReCa and a lot more consumption of glass pack products in HoReCa. So it's a key priority for collecting glass in many countries. And you're really addressing that convenience point at collection. Nevertheless, maybe one thing to be addressed is what Federico was mentioning at the beginning, right? The danger of crushing when it's mixed with other materials. One of the common issues that is faced with glass coming from the hospitality sector is the contamination from ceramics in particular. When you are placing these machines at the different HoReCa points, do you also accompany that with some form of education, let's say, communication to staff in the hospitality sector, or is the machine itself somehow designed to prevent ceramics easily getting in?
Correct, and that's a very good point. Look, everything starts with education. I think where we are today compared to where we were in 2005 when I started the company is two different places. The people that are working in HoReCa today versus then, obviously because the age changes, are educated in recycling, in the environment, in ensuring that the best possible use of waste and glass is done. If we talk about Ireland, when in 2005 there was landfill sites in Ireland. Today there's no landfill site in Ireland. So therefore everything type of waste is going for reuse or in a controlled environment. So when we put in machines into the hospitality sector, yes, we work a line of education. So because it's a machine, you have a circular opening into it, it's behind the bar, it's designed for glass, it's labeled for glass, people know it's for glass waste. And then the hotel itself will always have that as part of their induction with their staff. That, let's say it's the Hilton Hotel Group, they have a policy, they've implemented a waste management strategy, and as part of the waste management strategy, they're recycling their glass. This is the machine for recycling glass, and this is what we expect you to do. So when there's a machine there for glass, it's unlike bins. If there's a bin there, yes, we've seen it at the back of house. If you have bins for cardboard, plastic, waste, glass, and you go out and look at them, they're all mixed. If you have a machine for each of them items, there's less risk of contamination. With the machines for glass, we are monitoring. So we know if there is something going into it that's wrong. Okay? But over the last number of years, we can see the increase in compliance, and the companies collecting the glass can see that. We've worked very closely with a lot of the very large manufacturers of glass, and that's part of our policy, that we know exactly where the glass is getting to ensure that we can try at source to increase the volumes of glass they're getting. And it's increasing glass volumes as well, because we see it here in Ireland. They brought in the DRSI scheme for plastic. So now the emphasis is to get rid of plastic bottles. So you can see that our glass bottles are increasing, which is good. And I know myself, I use a glass bottle. It's not plastic when I bring water with me, because I like drinking out of glass. I ensure that glass, there's no leaches, there's nothing getting into the water from that. Whereas with plastics and PET, that has always been a huge issue.
Okay, brilliant. Thank you, Tommy. I propose that we bring in, all speakers. We have some 25 minutes or so for an open discussion. So please also raise your questions, raise your comments. I will be, raising them also with our speakers today. Just a first reflection actually on the poll that we did, so on whether people agree that making collection and collection logistics as convenient as possible is key. So there's a lot of leaning towards the fact that they agree that convenience is key. So 55% somewhat agree, 25% totally agree. Only 11% somewhat disagree, 8% totally disagree. What I find particularly interesting is that this topic leaves no one neutral. So there's 0% saying that it makes no difference. Okay, so that's actually quite interesting. My question to you, having heard from the different case studies, right, from the other speakers, what do you think today, now? Do you think that collection and collection logistics and making that as convenient as possible for operators, whether they are citizens, Horeca, retail, municipalities, waste management operators? Do you think it's key to go for convenience, even if it means crushing the glass? What do you think, Federico?
Okay, sorry, I was muted. I think it's always a balance of different factors that we need to take into account. For example, if we take the upstream collectors, they know, of course, how much they can save by crushing the glass, or how much they can save by how much crushing the glass. Maybe there are different steps. We as recyclers, we know for every type of crushing power that is applied, how much glass we can recover. And of course, the producers, so the bottle makers, they know how much virgin minerals cost against cullet that we can deliver them. Then I think all of this must be factored into a single equation to see what is the optimal amount of crushing that should be applied to the glass in order that all the system can benefit from it. Not only a single part, but all the system. Or not a single company, but all the environment.
Okay. Constantin, do you think convenience is king?
Well, it's outside my door because when you look at this aspect, my opinion can be different from the waste management company or collector or supermarket in the case of DRS or the municipality. Everybody has in mind goals which are not really the same. From my point of view as a recycler, I will say I will prefer to use a crush only when you need. If it's possible, is to avoid crushing for a better recycling. And I will say in DRS, I was mentioning, maybe some people will ask why it's crushed and uncrushed. Manual collection, it's they put in a bags and the bags sent to the counting center. There is no way of fraud, and in this way we can have a full glasses. Also, crush is accidentally and by purpose. In a DRS case, is by purpose to destroy it, or in a Horeca case, like we heard just before in the last presentation, you need to reduce the volume. So everybody's having his own goal. But from our perspective, we'll say use crush if you really need that as a recycler.
Mm-hmm. Yeah, because ultimately it's still important to get access to the material, and if the process is not convenient enough, you will not get that material in one way or the other. Simone, your view on providing convenience. I mean, you were talking about a door-to-door waste management system in Milan, which in principle is making it convenient for citizens. Do you think that is really the key in the collection model to make that collection act as convenient as possible?
Yes. Of course, convenient is the key for the quantity and quality of for everybody. I mean, we deliver services also to the Horeca sector, for example. We have maybe different collection frequencies for them, but the same system for everybody in Milan. So I think the key is to crush enough, but of course not too much, and maybe so we didn't actually go into this type of aspect, but maybe crushing crushing too little is the problem, for us that we collect. So we have the problem that some ceramic, some infusible can get in. So that's the problem. Otherwise, if the material is clean, I think there's no problem with that. So crushing, yes, but with care, I say.
Yeah, and also maybe to come back to Tommy, one point in relation to the convenience as well and the system that you're providing. So it's convenient under the counter. What happens in terms of the actual collection in the end? I mean, Are you delivering these machines to operators that are then running a private collection system? So they pay for a collection system that picks up this crushed glass from the equipment, or are you yourself offering a collection service to make it very convenient?
I suppose there's 2 points to make first. When we talk about crushing, first of all, the word crushing sounds like it's destroying. Okay, so yes, we've competitors in the market that bring the glass to sand or to dust. That's destroying it, right? And I suppose that's where we like to separate ourselves as a company. First of all, we don't want to destroy the glass. So the cullet that we're producing is from 8 millimeters up, okay? So that there is a value on it and that it can be used. So convenience is very important. And we talk about the knock-on effect of not crushing glass in city centre locations. If we take London, in London, where you have 9 million people within the M25, the volume of glass that's produced, if we don't look at reducing the volume, you've trucks going into the city centre, you've trucks going into congestion areas. For the hospitality sector, it's a huge issue because oftentimes there's traffic, there's cars, there may be cars in front of entrances to the back entrances of hotels and whatever, and then if they miss a collection, they don't have the room for storage. So you have to look at it from people's point of view. Convenience is always going to be people. If it's like a litter bin, if there's no litter bins on the street, they're going to throw litter on the streets. If there is a litter bin, they'll put the litter in the bin. So it has to be looked in 2 ways. We don't do collection of glass. However, we'll also always work with the hospitality sector to ensure that there is some provider within the area that's collecting the glass. So yes, we've partners in the likes of London, we've partners in Dublin, that we'll go to the hotel, bar, restaurant, and we'll say, here's a company, they're collecting the glass, but we know that that glass is going back for remelt because we've joined that dots in between. Okay, so whether it's Ardagh glass, whether it's Malta glass, whether it's Varelia in the UK, it's linked. Same in Ireland. So the black and white of it is convenience is always going to be very important. But you have to look at all the other things. You can't be all of one or all one side or not the other. You have to bring them all into the same equation. And that's why you have to look at logistics. You have to look at the emission side. You have to talk to the councils. You have to look at the different people that are involved in that chain. And what is it doing to make their lives better? And at the end of the day, everything we do as companies is what impact we have on the lives of ourselves and the lives of others. So that's why we want to work to recycle as much as we can.
So I think we established that convenience is key, and we also spoke about some of the specifications on the collection side. But then obviously when we talk about the closed loop, there are also specifications on the other side of whatever goes into remelt for new glass packaging. Federico, you were talking about the dangers of crushing glass too much and then making it more and more difficult to detect and sort out the non-glass materials, especially then the infusibles, the ceramics, etc. This is very, very key. What about just simply very, very small particles of glass as such? Do they also represent a problem for meeting the specifications of glass packaging manufacturers, regardless of the fact that there's contamination or not? I'm really talking about small or too small broken down glass being considered not accepted in the specifications for glass packaging manufacturers. Is that also a problem in addition to contamination?
Yes, so now I will step out a little bit of my working area and jump into the glass manufacturers area. So I might say something that is not fully correct, and please correct me. If you go below a certain grain size, then infusible might not be a problem anymore, especially if you go below 1 millimeter, let's say. So you can say, okay, my product is fully in spec, but in reality, then you have other issues coming into the game, like organics. So organics are like the papers, the labels, or the food, and so on. And this will also have an effect on the glass color, on the glass redox, and so on. And if you are in this very fine fraction, it's not possible to effectively remove this paper or this organic contamination from the glass. Then you still need to be in the coarse fraction to have like an effective cleaning, and then you can crush. But if you receive something that is already crushed, then yes, you don't have the issue on infusibles, but you will have the issue on organics, in my point of view.
Okay, Constantin, in your knowledge, in terms of the specifications from glass manufacturers and the density of the material, the fact that your material may have been crushed too much or the particles of glass are too small, can that be a problem for closed loop recycling?
Well, we won't like that is so much crush that is below our specification on our output. So we prefer to be crushed, but in a large pieces. And if this is possible, it's fine. What we are seeing today, and we are negotiating a lot with a machine producer, and will be the next step. What I collected for today was just initial stage. We need to enter in those machines inside the supermarkets and see what is the speed, how we can have a bigger what we are looking is for larger granulation to be a pre-crushing, not a crushing really as we do in the recycling. So a pre-crushing would be fine. We don't have anything against, because we have to accept what is coming from DRS. It's completely free of CSP. It's a dream to have such a material, and we make a compromise. But would like to cooperate. I won't say to teach them, but to cooperate to reach a level of granulation they are delivering to us crush material that fits to our possibilities to lose as less as possible and to be very productive, and finally to have a highest possible quantity in a closed loop.
Okay, does that have an impact, Simone, on the way municipalities design their collection logistics or impose certain rules on collection logistics? And have you seen that evolve over time? The kind of requirements that municipalities will have on the way glass is collected?
Yeah, of course. I mean, we are at the services of the treatment plants and of course the manufacturing process and the consortium that superintend this whole process. So yeah, I was thinking that we actually we have seen today so many different schemes, and all I think they all work in there, but of course the whole flow, must be addressed. So I think, for example, we say to our Horeca and to our citizens that we need the glass not to be crushed actually at all. Okay, at the minimum. So, for example, system like the one as Tommy was is presenting is not allowed in Milan. For we don't allow people or to crush the material, because we want it to have it as clean and as unbroken at the beginning. Then of course it gets broken on the way, but at the beginning we require this just for the quality, and that is and also we've gone through different because for example we had before the glass and metals collected together, then we evolved in only glass, and of course we keep changing because we collect also paper. In plastic there's been very many different types of collection. I mean, for example, the carton, the cardboard for beverages has been included in the paper collection. Somewhere else is in the plastic collection. So so we have to respond, and organic is always changing. I think glass maybe is one of the few that hasn't change so much, but all the different we try to keep up with the requirements.
Okay, brilliant. And maybe Tommy, well, maybe a reaction, because it's true that there might be some parts of the world where people say, well, hang on a minute, crushing can be a problem. So maybe just a reaction on that. And then I'll go on a final one also in terms of the developments in sorting, but maybe a quick reaction from Tommy.
Yeah, I think where the reaction is, and that's down to things of the past, where people were saying where glass was being crushed and destroyed and brought to a very small point. When we look at the technology, and it was brought up earlier on for sorting glass, like it can be sorted if we take whether it's Binder, whether it's Red Wave, whether any of these companies that produce glass segregation products at the moment, they can segregate down to a very low level. I think when you look at legislation, it's dangerous when you look at legislation where they do bring in legislation that you cannot do anything, because it then is not it's stopping innovation. It's stopping companies that are bringing in innovation that can solve problems from actually going into the markets. So anytime we hear the word cannot, we don't like it. I believe in our business, there's no such thing as we cannot do. We can do everything. There's nothing we can't do. So technology is changing, and I think that's why it should be always open. It should be always open to policymakers, that they don't make policies that restrict companies from coming into markets that may have technology and innovative products that can change, that can help the environment and protect the environment. And that's why I say we don't bring the glass to a dust like other companies that manufacture glass crushing equipment do. But there is markets. Look at the world's a big spot. We go after the low-hanging fruit first, and then we go after the long-term goals. And that's why, because you can't waste your time in a market where legislation has changed against it. But in time, that will change, because you'll have policymakers that'll come in and say, well, hold on a second, there's advantages to doing this. We have to do it.
So on that, I mean, you probably have a point on innovation in terms of the process. On the other hand, there is another rule that seems to apply in this area, is constant coherent communication to citizens, potentially then also HoReCa operators, and to some extent to have that stable over time is better, because it allows for adopting practices that comply with the in this case closed loop glass recycling. So there's a careful element to balance there. But on that last point from Tommy, in terms of the innovations in sorting that allow for much more, could we get a sense then maybe from Federico and Constantin on those developments and where you see the promise for the future? You know, will we be able to deal with ever more crushed glass? Federico.
Broken glass.
Well, I think the industry has grown a lot, because when I speak to my older colleagues, at the time they were only sorting glass bigger than 10 millimeters and only sorting CSP. Nowadays we can go to 2 millimeters. We have a plant sorting at 1.5 millimeter, and we're sorting green, flint, amber, dead leaf. We are shooting out lead glass. We are shooting out plastic, shooting out heat-resistant glass. So the technology has progressed a lot in these years. There are maybe some extra steps that can be taken. For example, maybe going into chemical composition of the glass itself, maybe to detect different shades of green, different shades of white, different shades of whatever. The point is always the throughput and the speed that you can get out of these sorters. Because for sure, you can even go to 300 microns, 400 microns, like people in the food and seeds industry are doing. But then you speak about 200 kilo per hour instead of 2 tons per hour. And then it's always an economical balance to take in. So recycle more, but also put more CapEx and OpEx on the table. So yeah, it's always a balance. But for sure, technology will help us a lot and has helped us a lot in the past.
Thanks, Federico. And a final word from Constantin on this innovation side while maintaining cost effectiveness.
Well, innovation has no limit, and I think what Federico says it's absolutely correct. I don't have many things to add on that. I will say that we really need to know the parameters. On one hand, we have a buyer, which is the companies, they use a cullet and they want to remelt and they want to have a quality packaging. On the other side, we have a flow. We are in the middle, so our technology should always adapt to the input, and the output is not so much changing, but input, it's clear. We discussed about crushing today. I will say crushing is not bad, but don't crush and destroy the material. If it's too small pieces, it's making our business very difficult, very unproductive, and we may have more material that won't go for packaging, but like we are trying to find solution today, should go for other application. Probably those fines may go to like a foam glass or other application, which are closed loop from material point of view, but not from product point of view. And I think we will continue to adapt to the condition, especially for the input. And I'm positive. I'm sure today also with artificial intelligence behind, we can have huge steps ahead.
Thanks a lot. Thank you so much to the four of you for having shared your insights. I think there's a lot of work going into the preparation as well, and I think we showed four very different perspectives on a very specific issue. You've been really helpful in bringing that forwards. Thanks a lot for having been with us.
Paul, thank you. Guys, thank you very much.
Bye.
Thank
Bye-bye.
you, Jean-Paul. Goodbye.
Thank you.
So, as you can see, when we talk about glass having a crush, it's not quite in the romantic sense, although I know that many of you will be loving glass. But what we can see is that a lot is possible. And we all agree that we have to make things as convenient as possible for whether it's consumer citizens or the HoReCa or the collection logistics. And there are a lot of efforts to make that happen. I hope you got something out of this discussion. We will certainly at Close the Glass Loop will continue to push on these good collection principles and all those steps after collection to ensure that as much material goes towards the closed loop. So if you want to get involved in our work, feel free to reach out to us either via the website, via our LinkedIn page. We're a very open community and we're always looking for inputs, for experts, for expertise. So please don't hesitate to reach out. It will be a great pleasure to work with you in building all of this value chain work that we're trying to achieve together. Thank you for having joined us, for your great exchanges in the chat, and well, see you next time. Bye-bye.